Yeah, so if you have had Calc 3, you can probably skip this video. This is just reviewing cross products or introducing cross products. So our idea here is that a cross product is a thing that only works in R3. So first things first, this is only in three-dimensional space. And what a cross product is I take two vectors. So I'm going to have here a vector v, I'm going to have here a vector u, and I'm going to produce a vector with three properties. So first property, u cross v, so this little x is how I'm denoting a cross product. Should be noted this is different than a dot product. So u cross v is going to be perpendicular to u and v. First thing first. So what I'm going to draw that with here is I'm going to say, all right, here's my, oops, that's not quite right. Here's my vector. That's going to be perpendicular to v and also perpendicular to u. So this is u crossed v here. The other property, second property that it's going to have, is that it's going to follow the right hand rule. So what I mean by the right hand rule is if you take your right hand and sweep your fingers the close way, so the short way, through u and then v, your thumb will point in the direction of u cross v. So what that means here is that if I sweep my fingers, right, my fingers are going to be swept around kind of this direction, right? U first, then v. So this is in fact pointed in the proper direction here. So that's my vector here. Now, that means that if I did v cross u, it points the opposite direction, right? So this is just a consequence, not something that we're going to put in as our geometric properties, but a consequence is that u crossed v is -1 times v crossed u, right? So doing it in the other order gives you the same vector but pointed in the opposite direction. So that brings us to property 3 here, because so far these two properties, first two properties, are going to determine a half line, right? Could be any place along this line. The third property is going to be that the magnitude of u cross v is equal to the magnitude of u times the magnitude of v times the absolute value of the sine of theta, where theta is the angle between u and v. Now, you probably don't really need this absolute value here. The reason you wouldn't need the absolute value, right, is that sine between 0 and pi is always positive, and the angle between two vectors can at most be pi. So I'm going to dump the absolute value here, but you can go ahead and think that exists if you want. It's not a bad thought. Like, it's a reasonable thing to think about putting in there. So I got magnitude of u, magnitude of v times sine of theta, and theta is the angle between the two vectors. And remember, that's got to be the close way. Meaning no cheating, no going around the outside. So my angle theta is in here. Should be noted that an alternative way of saying this one is that the magnitude of u cross v is equal to the area of the parallelogram. So I'm just going to call that the uv parallelogram. And in my picture here, that parallelogram is, here I've gone out by u from the tip of v, and here I'm going out from from u, the tip of u by v. So this is that parallelogram here. This is the uv parallelogram. Okay, and these three properties are enough. When we take Calc 3, we talk a lot about, or we end up doing a lot of what we call surface integration, right? We're trying to find the area of funny surfaces in space. And in order to do that, we need the cross product. So this is a thing that we're going to use quite a bit in Calc 3 if you haven't had it. If you have had Calc 3, this is old news, right? You know that we use cross product like, I think we start with cross products on like day 3 or something, and they like appear in multiple problems on the final exam. So like they're throughout the course, you should be used to using them. You might notice if you haven't had Calc 3 that taking a vector u and crossing to get a vector v, or sorry, crossing with a vector v to get that perpendicular vector, that's a thing I might think about with planes, right? Because remember, planes are kind of held by that perpendicular vector. So there's a reason I might be doing this in Calc 3. I think that's good enough as a, oh, we probably should calculate one. Sorry. Definitely not good enough. So here's how you actually calculate one. So I'm going to take here a determinant, and this is just a symbolic determinant. So I'm going to put I, j, and k as vectors here. So those are the usual basis vectors in R3. Then I'm going to put u1, u2, and u3. So those are the coordinates of the vector u. Then I'm going to put v1, v2, v3 in here. And this thing here, this symbolic determinant, is actually the vector u crossed v. So that's the symbolic determinant. To calculate that, I'm going to go ahead and use the cofactor method, right? So I'm going to be like, okay, so it's the determinant of u2, u3, v2, v3 times the vector I minus the determinant of u1, u3, v1, v3 times the vector j plus the determinant of u1, u2, v1, v2 times the vector k. And another way we could write that out, right, is we could write this out. We could go ahead and calculate these things, and we could make ourselves a vector. So here we should have a three-dimensional vector. The first component should be u2, v3 minus, clearly I need a little more space here. So it should be u2, v3 minus v2, u3. And then I'm going to need this guy, so that's going to be v1, v3, so that's going to be minus, u1, v3 plus v1, u3. And then we're going to do in our last coordinate, we're going to u1, v2 minus v1, u2. I don't expect you to memorize this, so don't memorize this. That's not useful. Memorize this instead. We're going to use a cross product a little bit going forward in the semester. Mostly I'm going to say, hey, remember all those times we used the cross product in Calc 3. That's really where this is super useful. You might also recognize the right-hand rule as a physics thing, right? There's like a torque thing. There's an electromagnetic field thing that uses the right-hand rule. That's all basically because of the cross product that this kind of happens. So this is your short little introduction to cross products. Go ahead and calculate a couple. Throw them in Desmos and check that they look perpendicular. It's a useful exercise, but I think it's something you should probably experience for yourself.